Okay, now we're just going to do a little bit of practice understanding what it is we've just shown you. Okay? What we're going to do is go through in detail an evaluation by informally substituting through the interpreter. And since we have no assignments or definitions in this interpreter, we have no possible side effects. Okay, so we can do substitution with impunity and not worry about the results, right? So the particular problem I'd like to look at is an interesting one. It's the evaluation of, quote, open, lambda of x, lambda of y, plus xy. Lambda applied to 3, applied to 4 in some global environment which I'll call E0. So what we have here is a procedure of one argument x which produces as its value a procedure of one argument y which adds x to y. We are applying the procedure of one argument x to 3, so x should become 3. Right? And the result of that should be a procedure of one argument y, which we will then apply to 4. Okay, and this is a very simple case. They will then add those results. Okay, now in order to do that, I want to make a very simple environment model. And at this point, you should already have in your mind the environments that this produces. But we're going to start out with a global environment, which I'll call E0, which is that. And it's going to have in it things, definitions for plus and times and I'm using Greek letters, isn't that interesting, for the objects, and minus and quotient and car and coulter and cons and EQ and everything else you might imagine in a global environment. It's got something there for each of those things, something that the machine is born with. That's E0. Now what does it mean to do this evaluation? Well, we go through the set of special forms. First of all, this is not a number. This is not a symbol. G, it's not a quoted expression. This is a quoted expression, but that's not what I'm interested in. The question is whether or not the thing which is quoted is a quoted expression. Right? I'm evaluating an expression. This just says it's this particular expression. This is not a quoted expression. Right? It's not a thing that begins with lambda. It's not a thing that begins with cond. Therefore, it's an application of its of an operator to operands. It's a combination. The combination thus has this as the operator, and this is the operands. Well, that means that what I'm going to do is transform this into apply of eval of, quote, open lambda of x, lambda of y. I'm evaluating the operator plus xy in the environment, also E0, with the operands that I'm going to apply this to, the arguments being the result of evlist, the list containing 4 in E0. I'm using this funny notation here for E0 because it should be that environment. And I can't have a name for it because I have no environment to name it in. Okay. So this is just a representation of what would be a quoted expression, if you will. The data structure, which is the environment, goes there. Well, so that's what we're seeing here. Well, in order to do this, I have to do this and I have to do that. Well, this one's easy, so why don't we do that one first? Okay? This turns into apply of eval, just copying something now. Most of the substitution rule is copying. So I'm going to not say the words when I copy, because it's faster. And then the ev list is going to turn into a const of eval of 4 in E0, because it was not an empty list. Okay? Onto the result of ev listing of the empty list in E0. And I'm going to start leaving out steps soon, because this is going to get boring. But this is basically the same thing as apply of eval. I'm going to keep doing this. The lambda of x, the lambda of y, plus x, y, 3, close, E0. I'm a pretty good machine. Applied, well, eval of 4, that meets the question, is it a number? So that's const, right? Const of 4. And ev list of the empty list is the empty list. So that's this. Okay? And that's very simple to understand, because that means it's just the list containing 4 itself. So this is nothing more than apply of eval of, quote, open, lambda of x, lambda of y, plus x, y, 2, 3, 3, applied to, well, E0, applied to the list 4. Bang. So that's that step. Well, now let's look at the next more interesting thing. What do I do to evaluate that? Evaluating of this means I have to evaluate, it's nothing but an application. It's not one of the special things. It's the application of this operator, which we see here. Here's the operator applied to this operands. It's that combination. Well, we know how to do that, okay, because that's the last case of the conditional. So substituting in for this evaluation, it's apply of eval of the operator in the ev list of the operands. Now it's apply of eval of, quote, open, lambda of x plus lambda of y plus x, y, lambda in environment E0. Apply that. I'm going to short circuit the evaluation of the operands because they're the same as they were before. I got a list containing 3. Apply that, and apply that to 4. Okay. Well, let's see. Eval of a lambda expression produces a procedure object. Okay, so this is apply of the procedure object closure, which contains the body of the procedure x, which is lambda, which binds x and has the internals of the body. It returns the procedure of one argument y, which adds x to y. Environment E0 is now captured in it because this was evaluated with respect to E0. E0 is part now of the closure object. Apply that to open 3 close. Apply to open 4 close. Apply. So going from this step to this step meant that I made up a procedure object which captured in it E0 as part of the procedure object. Now we're going to pass those to apply. We have to apply this procedure to that set of arguments. Well, but that procedure is not primitive. It's in fact a thing which has got the tag closure. And therefore what we have to do is do a bind. We have to bind. A new environment is made at this point, which has as its parent environment the one over here, E0. That environment. And we'll call this one E1. Now what's bound in there? X is bound to 3. Right? So I have X equals 3. That's what's in there. Okay? And we'll call that E1. So what this transforms into is an eval of the body of this, which is this, the body of that procedure, in the environment that you just saw. So that's an apply of eval, quote, open lambda of y plus xy, the body, in E1, and apply the result of that to 4. Open, close, 4. List of arguments. Okay, well that's sensible enough, because evaluating a lambda, I know what to do. That means I apply the procedure, which is closure binds one argument y, adds x to y, with E1 captured in it. And you should really see this, right? I somehow manufactured a closure. I should have put this here. There was one over here too. Okay, well there's one here now. I've captured E1, and this is the procedure of one argument y. Okay, whatever this is. That's what that is there. That closure. Okay, and I'm going to apply that to 4. Okay, well that's easy enough. That means I have to make a new environment by copying this pointer, which is the pointer of the procedure, which binds y equal 4 with that environment. And here's my new environment, which I'll call E2. And of course, this application then is evaluate the body in E2. Okay, so this is eval the body, which is plus xy, in the environment E2. Oh, but this is an application. So this is the apply of eval plus in E2 and evlist, quote, open x and y in E2. Okay. Well, but let's see. That is apply the object, which is the result of evaluating plus. So here we are in E2. Plus is not here. It's not here. Oh, yes, but it's here as some primitive operator. Okay. So it's the primitive operator for addition. Okay. Apply that to the result of evaluating x and y in E2. But we can see that x is 3 and y is 4. Okay, so that's to 3 and 4 here. And that magically produces for me a 7. Okay. I wanted to go through this so you would see essentially one important ingredient, which is what's being passed around and who owns what and what his job is. So what do we have here? We have eval and we have apply, the two main players. And there is a big loop that goes around like this, which is eval produces a procedure and arguments for apply. Now eval, some things eval can do by itself. Does a little self things here that are not interesting. Also eval evaluates all of the arguments one after another. That's not very interesting. Apply can apply some procedures like plus. Not very interesting. However, if apply can't apply a procedure like plus, it produces an expression, an environment for eval. The procedure and arguments wrap up the state, essentially the state of a computation, and similarly the expression environment. It's what we're actually going to do next. It's not the complete state, because it doesn't say what things, who wants the answers. But what we're going to do, it's always got something like an expression and environment or a procedure and arguments, and that's the main loop that we're going around. There are minor little subloops like eval through evlist or eval through evcond, or apply through primitive apply. But they're not the essential things. So that's what I wanted you to see. Are there any questions? Yes, David?
I'm trying to understand how x got bound to 3 instead of 4 at the early part of the...
Here. Mm-hmm. Here. You want to know how x got bound to 3.
Because x is the outer procedure, and y is the inner procedure.
Fine. Well, I was very careful and mechanical. Maybe first of all, I should write those procedures again for you, pretty printed. First order of business, because you're probably not reading them well. So I have here that procedure of, what is it, x over there, which is, value is that procedure of y, which adds x to y, lambda, applied that to 3, take the result of that and applied that to 4. Is that not what I wrote? Okay, now, you should immediately see that here is an application. Let me get a white piece of chalk. Here is an application, a combination. Okay? That combination has, this is the operator, and this is the operand. The 3 is going in for the x here. The result of this is a procedure of one argument y, which gets applied to 4. Okay? So you just weren't reading the expression right. The way you see that over here, okay, is that here I have the actual procedure object, x. It's getting applied to 3, the list containing 3. What I'm left over with is something which gets applied to 4. Okay? Are there any other questions? Okay, time for our next small break then. Thank you.